Welcome, everyone. Today's topic will focus on the benefits of using a photometer in the pool and spa market. I'll briefly discuss how photometry works, what features I think a test instrument should possess, how a photometer meets these expectations, and along the way, compare and contrast it with standard comparator color match and drop count test kits. Palintest offers a family of photometers for the pool and spa market. Today, I'm going to focus on the Pooltest 6. To use a photometer, you first read your sample water without any reagent. Then you add the reagent to your sample water. The water changes color, and the photometer reads the color change. How does it do this? It measures the amount of light that makes it through a sample to the detector. The darker the color of the sample, the less light will make it through. Initially, all wavelengths of light come out of the light source. An optical filter reduces the light to a single wavelength, which hits the detector. The amount of light that hits the detector is known as the percent T, or percentage of light that is transmitted from the light source to the detector. The instrument compares the two samples to determine the reading. So how does the photometer convert the percent T into a reading? The photometer has a unique calibration curve for each test stored in its memory. This calibration is determined in our labs. The calibration curve shown is for the standard range free chlorine test. The percent T value is converted to a milligram per liter or parts per million concentration using the calibration curve. And this readout is displayed on the instrument. Thus, 43% T is equivalent to 1 part per million. This continuous curve calibration provides precise readings throughout the curve. I'd like to share with you what I feel are the most important features of any testing instrument. We'll explore these with a Pooltest 6. Many think that all photometers are not user-friendly and thus intimidating. While this is true for some photometers, the Palintest photometers are designed with the end user in mind. With a Pooltest 6, the power key is on the bottom. The menu key in the middle will scroll through each of the tests. When blanking with the water being tested, the left key is used. When reading after the reagent has been added, the right key is used. The test tube holder is the optical chamber. The display screen is easy to read. Straightforward, not intimidating. It's easy to keep the optical chamber clean and reading well. Moisten a microfiber cloth with a foam or liquid electronic cleaner and wipe out the chamber. Accuracy is the ability to measure the actual value of a parameter being measured. Precision is the ability to consistently repeat the result. The Palintest photometers are both accurate and precise. The instruments have the ability to measure the actual value and can also consistently repeat this result. Comparator or drop count kits can often repeat the same result consistently, but without the accuracy of a photometer. I will be discussing the quality control that goes into both the instruments and the tablets, which assures you accurate and precise readings. The Pooltest 6 tests for free chlorine, total chlorine, pH, total alkalinity, calcium hardness, cyanuric acid, and bromine. The Pooltest 6 measures all the parameters that regularly need to be tested in commercial pools to keep your water balanced, safe, and clean. The Pooltest 6 photometer is available in either the 0 to 5 part per million or 0 to 10 part per million chlorine range. The Pooltest 6 is perfect for pools and spas. I wasn't working for Palintest back when these photometers entered the US market, and color matching comparators and drop count kits were the kits everyone used. I purchased a Palintest photometer, and it quickly became my preferred testing instrument because it was easy to use, easy to clean, accurate and precise, and did what I needed it to do. When relying on a photometer, how can the end user know the instrument is calibrated correctly? Is my source light skewing my results? And since we all know that the results are only as good as the reagents, what kind of quality control is provided? Palintest addresses each of these concerns. For example, check standards are used to verify that the Pooltest 6 is calibrated. Readings are done with the check standard vials, which are neutral density filters. A certificate is provided for each set of standards with values that the instrument must read to confirm the calibration. All the wavelengths on the instrument are checked when using the standards. If any reading is out of the specified range, the instrument will need recalibration. Check standards are a great tool to confirm the functionality of the photometer. The check standards have a 5-year shelf life from date of manufacture, are not affected by temperature, and can be used as often as desired. Most readings outside of the specified range are typically due to a dirty optical chamber. Simply cleaning your optical chamber can resolve the issue and save the cost of sending the instrument to be serviced. The Pooltest 6 test tubes have a cap which serves two functions. First, the cap prevents accidental spillage of water into the optic chamber. It also is a light shield which prevents outside light from interfering with the test. When color matching with a comparator, the result is quite dependent on the light source. Add to this, the brain judges color relative to surroundings rather than the objective standards, which makes color matching highly subjective. Color matching indoors adds an additional challenge that the manufacturers aren't consistent with how to test indoors. Go outside, use a white background, use a natural light simulator. How often are manufacturer recommendations even followed? The Pooltest 6 removes the variability of the light source and the subjectivity of color matching. Tablet reagents have a longer shelf life than liquid reagents. For example, the shelf life of the tablets used by the Pooltest 6 is at least 5 years. The tablets are individually sealed to prevent degradation from storage conditions or exposure to air. Liquid reagents have a short shelf life and once opened, begin to break down and are much more susceptible to environmental conditions. The Palintest instruments are durable and come in a hard carry case with the necessary accessories to begin testing immediately. Let's now discuss the accuracy of a Pooltest 6. To measure and meet the instrument's specification, the Pooltest 6 must be able to read within plus or minus 1% T. In this example, the 43% T is plotted on the calibration curve, which converts to the parts per million reading 1 part per million. Thus, to meet spec, the Pooltest 6 must be able to read within plus or minus 1% T which would be between 42% T and 44% T. In this case, between 0.96 and 1.04 parts per million. Tablets also go through a rigorous quality control process. The tablets must read within a tight range at different concentration levels. If the tablets don't meet these specs, the batch does not go to market. A certificate of analysis, or a COA, is generated for each batch, showing the tablet readings at each concentration level. COAs are available upon request for any of your tablet batches. Let's discuss some other concerns with comparator color matching and drop count testing. Here are a few that I would like to mention. Chlorine interferes with phenol red testing. Due to this interference, the Palintest phenol red tablets have thiosulfate added to prevent this interference from the chlorine. The thiosulfate neutralizes any chlorine, allowing for an accurate pH reading. If the chlorine is not neutralized, the pink color gets lighter due to the chlorine and results in a lower reading. So let's look closer at some of the testing we've done. We use a standard color comparator well known in the US. The blue bar shows the Palintest pH results. The gray bar shows the color comparator results. The four comparisons on the left side were samples with no chlorine in the water, but random pH values. Notice how closely the readings match the Pooltest 6 readings. With no chlorine interference, the readings were similar. The four pool samples on the right with various chlorine levels were compared. At 1 part per million, the comparator had a slightly lower pH response. But as the chlorine level increased, so did the difference in the pH readings. The higher the chlorine levels, the greater the difference in the pH readings. This is notable for two reasons. If the pH is tested at 7.5 with a comparator, but the actual pH is 7.8, that 0.3 increase is significant on the Langmuir saturation index to balance the water. If the pool manager calculated the LSI at a positive 0.2, the pool is within the desired range of negative 0.3 to a positive 0.3 for the balanced water. But the pool is actually a positive 0.5 and not within the target range. The second factor here has to do with the chlorine strength in his pool. At 7.8 pH, the pool has reduced HOCl, which equates to the chlorine being less effective than at 7.5. One solution to this chlorine interference would be to add liquid thiosulfate to the sample water before adding the liquid phenol red and obtain a more accurate result by neutralizing the chlorine. Operators report that this is not recommended by the manufacturer, as the thiosulfate has a high pH and will artificially raise the pH of the sample. In our tests with the color comparator, we used water with no chlorine present, so we could effectively measure the effect of thiosulfate on the pH. With no chlorine present, the pH should increase, but with as many as 5 drops, we found no change in the pH. But what happens when thiosulfate is added to chlorinated water? The chlorine interference is noticeable in the test where no thiosulfate was added. With the addition of each successive drop of thiosulfate, the pH level began to rise until all the chlorine was neutralized. The pH reading becomes similar to the Pooltest 6, somewhere between the third and fourth drop. In this last comparison on pH, liquid thiosulfate was added to both the 10 milliliter Pooltest 6 sample and the color comparator. Since the chlorine is already being neutralized in the Pooltest 6 test, one would expect the pH to increase with the addition of 10 drops of thiosulfate. But as you can see, the Pooltest 6 pH remained the same, and the comparator had a similar pH after the addition of 3 drops. By eliminating the interference of chlorine in the pH test, Palintest photometers ensure a true pH reading. Palintest was founded by Dr. Palin, who was the inventor of the DPD method for analyzing chlorine in water. This was the first accessible method for analyzing chlorine levels in water and allowed everyone to get meaningful results in the field. His first DPD test that he developed was FAS DPD, which uses the DPD powder and then titrates from pink to clear for free chlorine. Then the respective DPD liquid reagent is added, turning pink from the presence of combined chlorine. This is then titrated to clear for the combined chlorine result. But Dr. Palin discovered that a 2 to 4 minute wait was required for full color development of the combined chlorine before the titration should be started. This procedure is still the same today, yet FAS DPD kits do not typically specify any wait time before titrating for the combined chlorine. If the wait is not followed, the titration begins immediately, giving a false low result. Since the result is combined chlorine, many are happy with this false lower result. But in my experience, most are not aware of this issue. The Palintest DPD colorimetric method that the Pooltest 6 uses for total chlorine requires a 2-minute wait as part of the protocol for this test. In this chart, we tested 10 pool water samples. The blue bar is the Pooltest 6 total chlorine result after the required 2 minutes. The lightest gray bar shows the FAS DPD result if titrated immediately. The medium gray bar titrated after 2 minutes, and the darkest gray bar after 4 minutes. It is clear that waiting the 2 to 4 minutes when doing the FAS DPD method gives a better indication of the combined chlorine, just as Dr. Palin established. The CDC offers recommendations for treating fecal accidents. If a pool needs to be treated for a possible cryptosporidium issue, the test instrument must be able to measure below 15 parts per million for cyanuric acid, if cyanuric acid is used. The Palintest cyanuric acid test has a range of 2 to 200 parts per million. If we look at a typical comparator cyanuric acid scale, the lowest it can measure is 30 parts per million. Another test where the Pooltest 6 shines is calcium hardness. Metals can interfere with the calcium hardness test. Iron and zinc are typically low in pools and won't interfere, but magnesium will interfere and be counted in the measure of calcium, which can definitely be an issue. Palintest calcium hardness tablets are specific to calcium without interference from the typical levels of metals in pool water. Calcium hardness reading with the Palintest test. A drop count hardness test result will typically be higher than the Pooltest 6 due to the magnesium interference. Another issue with drop count kits is the inconsistency of the drop size depending on the angle the reagent bottle is held. Static electricity can also affect the drop size, as well as will the age of the bottle tip if the bottle is refilled repeatedly. Cross-contamination can happen if reagent bottle caps are accidentally interchanged or a bottle is refilled with a different reagent. I hope this webinar has raised your awareness of some of the key differences between a photometer and a comparator and why the Pooltest 6 has always been a personal favorite of mine. Palintest instruments have been thoroughly designed for ease of use and reliable results. They put state-of-the-art photometry at your fingertips, allowing you to confidently balance your water, extend the life of pool equipment, and increase bather satisfaction.